This video is going to demonstrate the difference between a modified stethoscope used for ear insufflation and an instrument that is specifically designed for ear insufflation. They look similar, but they're totally different, and by the time we get done with this, you'll see why it's important to have a proper instrument when you're delivering ozone via ear insufflation. Traditionally, the modified stethoscope consists of a metal hoop. It could be aluminum, it could be stainless steel, it could be plastic, and then they have some kind of a polymer, a plastic, rubber earbud that goes into the ear. It seals. We do not want to have a seal in the ear for ear insufflation. We want to have free-flowing ozone, no seal. Some, to help alleviate that seal problem, they put a little moistened 2x2 between the bud and the ear, and that further degrades the ozone that's already degraded because of the instrument, the way it's delivering. So, and then it goes into which usually comes with a silicone tubing, rather large. Usually it's 3 to 4 millimeters internal diameter, and it's about 48 inches long. And so that's typically what you see as a modified stethoscope for ear insufflation. We're proposing that you consider an instrument that's been designed specifically for ear insufflation. Looks similar, but it's not. Start off with, it has earbuds that are designed, CAD machined and designed for this application. You'll see in the center of that earbud a very fine small hole. That's 1 millimeter diameter, feeds a 1 millimeter diameter Teflon tubing that goes inside this metal tube, inside the silicone, and to the source of the ozone. And on the outside there are 4 holes on each earbud, and they pick up the spent ozone via vacuum, and that's pulled down the tube, down the silicone, into our package here. And we have a very handy package. It consists of a oxygen cylinder, regulator, an air pump that pumps and pulls the spent ozone from there into a destructor, into the muffler, and into the pump, evacuating all spent ozone so you don't have the ambient ozone. It's mounted with a generator that puts out up to 120 micrograms per milliliter. So let's turn off the pump. We don't need it right now. And then we'll be testing with a Medizone ozone analyzer, and our timer here is gone on vacation, so let's wake him up. Wake them up. There we go. And we'll zero out our analyzer. Put air through there. Okay, it's zeroed out. Now let's go ahead and test. Now what we're going to be testing for is the peak level of ozone and how long it takes to reach that peak in each of these two instruments. So we'll connect both earbuds up to the Y that'll draw the ozone into the analyzer, and then that connects to our generator. Okay, we run it at 1/32 liter per minute. Let's get a focus on this so we can get real close so you can see the numbers. All right. And we'll hit simultaneously, we'll hit the timer and the generator at the same time. So let's go ahead and start. Now, as I said, it's 4 millimeters diameter, so it's going to take a long time to get from the generator to the actual analyzer. This is time spent. You think is the patient's getting ozone, but they're not getting ozone, not for a whole minute and more. And then when it arrives, it's going to be, you'll see it. It'll be much less concentration than if it's delivered by Teflon. So again, we're watching the ozone level here, and we'll catch it at its peak. In other words, when it reaches the top and starts to come down a little bit, or starts to fluctuate between a peak and just close to it, and we'll stop it at that point, and we'll do the same thing with the Teflon tubing. So we're seeing movement beginning right now, and so as that's 58 seconds, we're at 66, 69, 70, 75, 80, We're at 1 minute 3 seconds at 86, 88, 89, 90, 92. Actually, I touched it for a second, excuse me. 94, 95, 94, 95. Let's call it right there. 1 minute and 21 seconds. 1 minute and 21 seconds. And the level was 96. Let's turn off the generator. Let that flush out. We'll speed it up by turning up our oxygen flow just to flush it out more quickly. There's a lot of area in that tube. That's why you should be using the least length you need and the smallest diameter tubing. Otherwise, you spend a lot of time with ozone traversing through a tube that, frankly, is breaking down as it's traversing, let alone interaction with the tubing material itself. So we're now at 1/4 liter per minute flow, actually 1.5, and it's still teetering around 1 to 2. So let's turn this back to 1/32, take this off, put on the ear insufflation instrument, do the same test. I didn't mention on the ear insufflation instrument we have a very soft silicone tip that goes on there on the earbuds. It's disposable. You exchange it for each patient, and you can see it helps become a little more hygienic in the ear there. There's a disposable tip right here, and it comes off easy on and off. Anyways, another additional plus to this instrument. So let's connect it up. Same yoke, same everything. Tubing's the same length, only different diameter and different material. So we'll hook it up to the generator. We've got our 1/32 liter per minute flow. Reset our timer. And we'll zero it out. Okay, it's flushed now. Let's go ahead and start. And as I told you, it's going to be a little bit quicker, so we'll be ready to stop it when it hits its peak. At 10 seconds is usually when patients start to feel a warm glow. So see 111, 123, 126, 127, right there, 127 at 17 seconds. 127 at 17 seconds. 127, 7. We'll call it 18 seconds. We'll round it up. So 18 seconds, 127. And the other was 139. And reach 94. Okay, so that's the difference you see is significant. 139 seconds, it reached a peak of 94. With the 1 millimeter diameter Teflon was 18 seconds, it reached 127. So a significant difference in both concentration and a great deal of time difference. And both of them will impact the treatment result. So again, if you're going to do ear insufflation, you use an instrument that is appropriate and properly designed for that application. I need to show you that they're both the same length, so let's do that now. So we have both hoops together, both have yokes, and we just pull them all through, and they're both the same length material. Okay.